is the next thing that I'm doing isn't going to take that much time. So you guys could pause your progress for a moment and just pay attention to this one and try it out in a clinical environment, which basically means you can just try it out in a place here and there and reapply the completed pattern later, which we're going to have to do anyway. So what we're going to be doing is using this very simple Grasshopper definition to apply guardrails, or basically just like an edge or rail to the end of our surface, right? It's well, you'll see, right? It's simple, and I think it provides a pretty cool level of elegance to a simple model when you're studying it in a schematic fashion. So we still have that surface at the top. I did mention not to delete it. If you did delete it, you can Control-Shift-click that top surface and make a copy. But this is set up to use a curve, right? And what it is it's just generating a rail at the edge of your surface. Okay, so so very simply put, here in perspective, and actually let me pull this up a little bit so that we can kind of see the building overall. All right, so here in perspective, right, we have these, they're almost like platforms that are kind of extending out over space, and mine doesn't have like a wall that's right there, so I need to bound that thing with an edge. So this top surface, you can actually get the edges of these top surfaces, and hopefully when you grab the three of them, you turn off the ISO curves, which is found in your properties view right here, and then switch to object. Turn off show surface ISO curve. It just kind of helps a little bit with cleaning up that extra line that this is going to create. So what you do is you type in extract wireframe, and what that did is it took the profile of those three surfaces and it actually created curves with them. So you'll see if I pull this out, those are curves now. They're not surfaces. Anyway, but I'm going to leave them where they are, and here's why. When I right-click on curve and I say, for instance, right now I'm just going to set one, but I say set one curve and I click here, it creates a rail. And this rail is pretty dynamic. You know, you have some flexibility with it. I'm not going to get crazy with the Grasshopper definition, but very simply put, as long as you if you change these things, you can reduce the 6-inch offset at the bottom to be exactly flush with the bottom of your plane, or bump it back up to 6 inches and lift it up a little bit, or you can even go a little higher and make it 12 inches, or potentially if you wanted to get a little crazy with it, you can go up to something like 30 inches and then make a copy of this thing, and then change your bottom height down to 6, and then make this go up to I don't know, 26, something like that, and you can create a double. Okay. The other thing you can do, let me go back to the original one though. Whoops. There we go. Yeah. The other thing you can do here is change the number of panels. So right now these are 6 very wide and long panels. You can increase that. Right now it's up to 10, but you can change that slider to make it something that's going to be more appropriate for your design as well if you want. I'll kind of leave it in the middle for now. But then also you can change how big these panels are inside. There you go. You can change how big those panels are or how small, however you want to refer to it. And this is a percentage of the original full-size panel. So feel free to explore that, but don't make it like this tiny little thing in the middle, because it's not going to be believable, and then of course the panel thickness is adjustable. You can increase it, make it thicker or thinner. It's up to you. It's going to read a little differently in your model. And lastly, the pipe diameter. You can make the pipe diameter more robust, or of course you can thin it out a little bit. Okay, so it's a pretty flexible definition. It's very simple. Don't get too crazy with it, but really the objective here is that we're actually going to go through the process. We're going to manage this and start adding in areas that we want to actually bound. Okay, so this works in all cases. It also works in curved conditions. So if I manage that collection and I add in this curve at the front, okay, there you can see that it goes around that curve as well. And the coolest thing, I think, is, well, it's actually to come in the next segment, but let me pause for a moment and just get, well, no, I won't pause. The other thing that we're going to do is start to integrate ramps and stairs and stuff like that. So let me pull this off to the side, and I'm going to operate just here on Rhino for a moment. The stairs that we're going to be doing, it might make sense to make a new layer for it, but that part's kind of up to you. I'll make this magenta. If you're creating a stair, right, you need to think about, well, what is the slope of the stair? How big does it need to be? So generally, rule of thumb is a minimum of 4 feet. For schematic design, we tend to just say 4 foot for the width of a stair. That's good ballpark. Or if you need to go wider, that part's up to you. But what you should know is that on any stair, right, the rise and the run, right, so that would be your riser height and your tread depth is what's going to determine the slope of the stair. So schematically, we're going to show it at a tread depth of 11 inches from nose to nose and a rise of 7 inches. That's kind of a ballpark number. So how do you find out what that slope is? Well, you could do the math on it, or you could just very simply here do a polyline that goes 11 inches. Go that way. Wait, that wasn't 11 inches. 11 inches. Oh, line. There you go. Hang on. 11 inches. And then you're going to have to zoom. There we go. Go there. And then 7 inches. Go there, and then just go all the way back there. And so you can measure the angle. Let's see. Where are the dimension features? I haven't dimensioned anything in ages. Radial dimension. No, sorry. Dimension, angle dimension. There to there. So that's 32 degrees, right? So that's like, you could do the math, and like SOHCAHTOA and all that, and do your trig and figure that out, or you could just draw it and measure it. I like doing it that way. Yeah, that's a funny topic between me and my fiance. We go back and forth. She's much more of an engineer, so she goes like the math route, and I go just give me a software package and it'll tell me. Anyway, so that basically, to me, what that means is this, right? We can create a ramp very, very simply, or not a ramp actually, a stair, schematic stair, by basically drawing the plane. So you can just do a rectangle, say 4 feet. Actually, let's just make it like I don't know, 15 feet by 4 feet. Ah, crap, did it wrong. That's going to be at 15 feet by 4 feet. It looks like that. That's really, really small. But I'm going to move that into place. Put it right here. And actually, I probably want to turn project off because then it'll be easier for me to just say move and go from here to there. And that puts it in the proper location. Then I can rotate that from there to, and I have near on, so it's going to be perfectly placed right there. Oh, this is still a curve, sorry. I'll make it a surface. Planar surface. Okay. So this is the ramp. Make it so you can see it. This just needs to be rotated, so I can align my C-plane to the object. So let's see, we'll align to object, and then I can click on that green one and just rotate it 32 degrees. And that went 32 degrees down. So hang on, which way am I rotating? It's going that way. So I'll go, yeah, 32. Right? Whoops. we go. So that went 32 down. Yeah. Move that into place there. So that's essentially the slope of the stair. So there are going to be a few things you need to do. In a few cases, you'll need to kind of figure out, how do you go 20 feet, right? So this thing needs to actually go down a certain value to get to 20 feet. We could use trig for that if you wanted. But yeah. But basically, another cool thing that you can do is just, you can eyeball some things. Since it's so schematic, just copy this thing, flatten it out by going backwards, -32. I should have just made a copy of this originally, but yeah. Hindsight's 20/20. Pull this back. You can use the distance command to measure how big that thing is. Right now it's 5.28 feet, so I'll grab that edge and move it this way, 0.28 feet. 5 feet, looks good to me. I'll make this double as far, so I'm going to make this 4 feet wider. And then I can mirror this from here to here. So that makes one on the other side, right? You guys are starting to get the feel for this, right? Then I should mirror that again from here to here. Get rid of that original one, move it down. Now I've got a ramp that's going down. So what you'll need to double check here is that your ramps are, basically making the appropriate elevation change that you needed to make. So, if you wanted to do all the pre-work, you can do that. But really, there are a lot of things that we can do differently. So Control-Shift-Click, I'm going to grab that. And what I'm going to do is move this from a point that goes from here to there, and it just extends. Oh, look at that, it stopped a little short. Move there along near, so it stays in plane. So that actually extends a little bit below the surface that I'm working on. You guys see that here, kind of sticking down below my actual floor plate? That's this one. Well, the cool thing is I still have my surface there. So I can very easily just trim, grab that surface as the cutting line or object, and then just trim that off. Right, so now I have my ramp actually goes down to a platform and then down there, right? So, and this isn't anything super special right now. It's actually kind of ugly. I haven't actually fully designed it to actually relate to my architecture or anything like that. But here's the reason I did it so fast. Okay, back to the Grasshopper definition. The coolest thing about this definition is that when I extract this wireframe, right now I have an edge curve. I can actually go to my Grasshopper definition, right-click that. Whoops, I did that wrong. Manage the curve collection and add this curve, add that curve, and just do it around the whole ramp. And when you hit OK, that definition applies to the stair as well. Right. So if you need, here's another point to make. Right. Like these are really wide, and there are a bunch of them, and these are really tight, and there's the same number of subdivisions even for the smaller definitions. What you probably need to do here in this case is make a copy, and for the really long ones, you want to set multiple curves and then pick a curve here, curve there, wherever else they occur, and leave it. Oh, look at that, it didn't deselect the other ones. Hang on. Oh, it did. Oh, that's right, because this one was a copy. And then this one, you're going to want to set multiple curves for a different value. So we'll go curve there, curve here, hit enter. So then this one can stay, with a different number of subdivisions. You can make it, oh, that's wrong. There we go. Subdivisions here. Go with like 8 or 9 subdivisions, even 10 for those really long ones. And then when you get down to the stair, this one's going to have far fewer. Maybe only 3 subdivisions, right? So are you guys kind of getting what the intent is here? Is we basically want to show the boundary of where our users are going to travel through the space. Okay, and I want you, so here's the objective that we're trying to get at, and you probably want to start not with the Grasshopper definition, you probably want to start with your ramping and stuff like that. You want to be able to get from the outside where there's a drop down into your space, or you can translate from the drop to one of your platforms, and then you want to get through the space all the way up to your top level. Okay, and it's up to you to kind of just, you know, be creative with it, relate it to your architecture in some way if you can, but it's pretty much a path-based exercise. Okay, and you can have multiple paths if you choose. So do you have any questions about that? They're going to look like ramps. If you want to go through the process of modeling the actual steps, that's up to you. That's not necessarily part of the assignment. But if you want to actually make steps for like a portfolio reason or something like that, by all means, go for it. What other questions do you have? It's all right. I'll be helping you out. Here's the key, Scott. Start by just, you know enough of Rhino to do ramps like this, right? And I can go through with you some of those shortcuts that I just did, but I think you know how to make planes, rotate planes, and stuff like that. So just think about moving through your space as, you know, like a path-based concept. And this is for all of you again. I want you to be thinking about the narrative of moving through your space. What are you showing? What camera angles are you using to show how you move through the space? Okay, so most importantly, like what I mean by that is if I'm standing on, or if I'm entering into my model and I'm moving up to this platform, this view doesn't tell me much, right? Like I see a ramp in the middle of nowhere. But if I'm changing my, let's see, viewport, there we go, 22. If I'm changing this, if I'm changing my lens length so that I can actually show perhaps where I came from, like maybe I'm standing on the edge and I can actually see the stair cascading down to the level before, and then I see the stair rising up to the level above, right? Like think through the narrative of what happens on your different levels. And down here, if I'm entering into my space, right, I'm going to start here. I'm going to see this ramp go down and then even potentially come right back up, or I'm going to see the land bridge or some, you know, stair-based connection that brings me into that space in some way. Okay, so I just want you to be thinking about that as you're producing these views. Like, what do you see? You know, do I see my whole building kind of rising up in this image? That kind of stuff. And get creative with it. Huh? Well, yeah, I mean, you're not going to be there yet, right? We've got a lot to do. You got to think through like ramping and get our, you know, floor plates ready to go and all that stuff. So anyway, I'll be around to help you guys out, and I'll probably do a couple more supplementary tutorials and stuff here and there for pro tips.